Hello everyone, welcome to this talk on geographic visualization. I am Nirmal Malapaka. I'm a kernel developer here at Wolfram, and today I'll be talking about some of the new features in geographic visualization. Before I get started, a few housekeeping points. If you are listening to this talk live, you can download this notebook at the Wolfram Technology Conference website. If you have any questions, you can put them in the chat box and someone in the visualization team will be able to take a look at them. And finally, if you are interested in interacting with visualization developers, there is a developer office hours that's scheduled for 2 p.m. this afternoon, I believe. And so I'd encourage you to attend that session. So with that out of the way, let me get started. In this talk, I will show you some of the new geographic visualization features that we've been working on for the past year. I will also show you some of the improvements that we made to already existing functions like Geolistplot and Geo Region Value Plot. And then we can look at some of the new functions that we've added, and then finally explore some real-world data that showcases the features and functions. So at the technology conference last year, I gave a talk on geographic visualization that dealt with how different GeoVis functions handled various data. In this talk, I'll be much more narrowly focused on the new functions that we have added, as well as improvements that we've made to existing functions, and some new options. So we added 3 new functions: point value plot, geograph plot, and geograph value plot. We made some big improvements under the hood to Geo Region Value Plot in Geolistplot. And so I'll be showing you what those are and what that means from a user perspective. And one option that's worth mentioning is color function binning, which is a new option that we added to Geo Region Value Plot. And so we'll take a look at what it is and how it works. So let me start with the improvements that we made to Geolistplot. Both Geolistplot and Geo Region Value Plot have had a big revamp of the code, and they both now have new parsers. And so what this means is that we are able to bring both of these geoplots much more closer in features to some of the scientific visualization functions. And so we'll see why that is important in a bit. So here is an example, and I will be covering these updates via 2 main sets of features. One is plot markers and the other is wrappers. And so here's an example of Geolistplot that is plotting 3 locations in France. And Geolistplot and Geo Region Value Plot, both of them have been able to plot geoprimitives for a long time now. But what this example shows you is that with plot markers automatic, we are able to ask Geolistplot to represent these locations using much more traditional plot markers that you would expect to see in scientific visualization functions like, say, Listplot. And so with plot markers automatic, you can see that these locations are now being plotted using 3 different styled plot markers. This comes in handy in a few places, and it enables us to do some interesting things. So one of the things that we've done with this is the first example on this slide. And you can see that Geolistplot is plotting 3 locations here, 2 of which are countries and 1 is a city. And so when we plot this, you can see that the city is being represented as a plot marker. This is important because sometimes, depending on the scale of the plot and the range that we are plotting it on, some of the locations can become quite small and difficult to pick out. And so having the flexibility to switch markers enables us to build in some automated behavior whereby if a location falls beyond a certain threshold, and then we can switch it to a plot marker and by default use a color for the plot marker that stands out a little bit more. And so we are able to see even the small locations on a map. And so that's what this example demonstrates. And the second example shows us that this flexibility also extends to how we represent the locations in general. So now we are able to use a whole range of primitives, both geo primitives and graphics primitives, directly to represent the locations using Geolistplot and Geo Region Value Plot. And so here we are plotting a geodisk to represent the location of Paris, but we can just as well use any of the geo primitives or graphics primitives to do the same thing. And so that brings a new level of customizability to these plots. The other big set of features that I want to show you are related to wrappers. So wrappers are something that all visualization functions have built in, and it's something that gives us a lot of control over how we want to plot different elements inside a visualization. And the scientific visualization functions, as well as charts, have had this functionality for a long time. And with the new update, we are able to bring much wider support for wrappers to Geo Region Value Plot and Geolistplot. So in this example, Geo Region Value Plot, we're plotting the 4 countries, 3 Baltic states plus Belarus, and we are styling them according to their GDP. But what we want to do is we want to attach a tooltip to each of these regions. And so that's exactly what we've done here, where each region gets a tooltip with that region's flag. And so when I hover over these regions in this plot, you can see the flag of that country appear as a tooltip. Another improvement that we made to Geo Region Value Plot is to add a new option called color function binning. So here is an example where we are plotting the military expenditures of NATO countries using Geo Region Value Plot. And as you can see, the legend here by default is a gradient. And so sometimes it becomes hard to pick out the precise value for a color that's being represented in the map. And so what we decided to do is to have a feature whereby we can bin the colors. We can classify the colors into different bins and then use these colors to style the regions on the map. And so if we use color function binning automatic, in this case, you can see that the legend now reflects 4 binned colors, and those are being used inside the map to style the regions. This is not very optimal in the automatic setting for this specific plot, because you can see that, there's not much variation among countries, and the way the styles are being chosen based on the binning of the values. And so color function binning comes with a few built-in methods. So one of them is a quantile-based method. And so you can pick color function being quantile, And you can see that that automatically increases the number of colors based on the values. And then we are able to see more variation in the different regions in the plot. There is a cluster analysis-based method for color function binning called k-means, and that further improves the way the elements are styled, and we're able to see more variation again. You can also specify your own custom ranges for the bins. I've not used an example here to demonstrate that, but if you go to the documentation page for color function binning, you'll be able to see all the different specifications that can be used for this option. The improvements to plot markers that we talked about for Geolistplot also are carried over to GeoRegionValuePlot. Value Plot. And so here we have a plot of the European countries, and they are colored by their population. And here we are using plot markers again. As you can see, there are two settings for plot markers. One is automatic, and the other is automatic, point. So the plot on the left by default uses polygons to represent all the regions, whereas the one on the right, which uses automatic, point, then switches between using polygons or plot markers to show the smaller regions. Plot markers can also be used to specify what kind of marker you want to use for those smaller regions. And so here's an example where the plot markers setting for the left is forcing polygons. So even the small regions are being plotted as their geopolygons. Whereas on the right, we are forcing the smaller regions to use a pin-styled plot marker. So that's the polygon for the larger regions and the geomarker for the smaller regions. So that brings us to the end of the improvements that we made to existing functions. So now let's switch over to the new functions that we've added. Point value plot is a new function that we added in version 12.2. It's a function that plots points and styles them based on their values. What makes it interesting for us for this talk is that it accepts geopositions. And so here we're generating a set of random geopositions in the United States. And then we are associating each of those positions with a value. And when you give point value plot geopositions, it plots those positions on a map, and then it styles them based on their values. And so you can see here that we have these random geopositions, and based on the value, the color of the point is being changed. We have some control over how we want to encode the value into the plot. And so the second example here shows you that the second argument to point value plot is a way to specify how we want to encode the value into the representation. And so here, instead of varying the color of the disk that represents the locations, it's varying the size. We can, of course, do more interesting things with point value plot. And here you can see that we're generating a whole bunch of random geopositions, and we're associating a list of values with each of those positions. And then we're using this option here to specify that we want to represent each of those positions with a bar chart that plots the list of those values that are associated with that position. And so this is a very interesting way to display data which is connected to one specific location, but then use a different visualization to actually represent that position. So we'll look at how this will be quite useful when we look at the example that we'll be working on. The second new function that we've added is Geograph Plot, and we added this in version 12.3. And Geograph Plot takes a set of values and it plots them as a graph on the map. And so here we are plotting the sister cities for Chicago, and it interprets each of these cities as the vertex of the graph, and the line that connects these cities will then become the edges. Geograph Plot is a nice example of how we unify different visualization paradigms. So this graph, this plot shows a nice way in which we unify the graph paradigm with the geo paradigm with the visualization paradigm. And so you can see here that this function has 3 sets of options. So we have a couple of geo-based options. We have one graph-based option, and then we have a plot-based option. And so this is the same exact data from the previous plot that we are plotting, but now we are specifying using the graph layout that we want to plot the graph edges as geodesic paths instead of straight lines. And then we are using the plot theme to specify that we want to label the vertices or the cities, the positions of the cities based on the graph's vertex index of vertices. And so this is a nice example of how Geograph Plot is able to unify these 3 sets of visualization paradigms. So this brings us to the last new function that I want to talk about today. And this is a new function that we will be releasing with the upcoming version of the Wolfram language. This is an extension to Geograph Plot. And what this does is it attaches a value to every edge in the graph. So here you can see that, so these kinds of plots are useful to represent flows, like trade flows and traffic flows and things like that. And so here in this example, you can see that we're representing the trade between the United States and Europe, China, and South America. And so if we take this edge, for example, so that would be the edge of the graph connecting United States to Europe in that direction. And then if we hover over it, we can see that there is a value attached to it, which is the amount of trade that goes in that direction. And we also get a nice legend for it, which shows the correspondence between the thickness of the edges and how they correspond to the values, as well as the color encoding. And so I think that brings us to the end of what I wanted to talk to you about with the updates to the existing features and the new features that we have added. Now I want to look at how we can apply some of these new functions to a real-world data set. And so we'll take a look at the Menard data set, which looks at the French invasion of Russia in 1812. And so this data set has a few different types of data associated with it. And so let's take a look at them. First, it has the locations of the path along which the invasion took place, from the town of Kono to Moscow. And so there are geopositions associated with those locations. And then we have the temperatures along the path of the invasion at some key locations. That's this set here. And then we have the geopositions and the troop strength associated with each of those positions. So let's take a look at how we can explore this with the features and functions that we have seen so far. So let's first just plot the locations directly using Geolistplot. And so we have locations here, and we're plotting the Geolistplot. With the new wrapper support, what we can do is we can attach a tooltip to each of those locations. Each of these locations is a geoposition. And so I've attached some paintings that depict the invasion to each of those locations. And then I'm using GeoMarker so that I can use a pin style marker for each of those locations on the map. And so now if I hover over these locations, you can see that there is this painting that documents the invasion that is associated with that location. So that makes it a little more interesting to explore. Now let's look at the second data set, which has the temperatures of some of these locations associated with it. And we have GeoRegionValue value plot here that we are able to plot. And I'm using color function binning to specify how many bins I want. And you can see that I'm using geomarkers, and it's picking up the colors based on the temperatures that are shown in these bins on the legends. And so you can see that this is an interesting way to look at the temperature data, which is to see where, which location has what temperature during the invasion. So let's look at the third function, Geograph Plot, and see how we can use that to explore this data set. So Geograph Plot here, we're doing first, we start off by doing a straight plot of those locations as a graph. And so we get the vertices of the graph as the locations that are represented by the geopositions. And then they're simply connected using straight lines. We can do some improvement to this plot using some of the options. So let's do that. In the previous plot, we were using geopositions for these locations, but we can, of course, pull that data directly from Wolfram Alpha, and that's what we are doing here. And these cities are taken directly from Wolfram Alpha and plugged into Geograph Plot. When we do that, we can use a few automated options like vertex labels name, which is able to go into that Wolfram Alpha entity, get the name out, and then label those positions using that name. We are also using graph layout walking, which is able to look at the street data from the maps and use that to connect the vertices of the graph. And so if we were to track this path today, this would probably be the closest path that we'd be taking. We can, of course, just simply rely on the labels that come from the map directly so that we get labels not just for the locations that we are plotting, but also the surrounding locations. And so we are using Geo Background Street Map here, and we're still using graph layout walking. And this is an easy way to overlay the information that we have on top of a street map. This is a similar plot for the return journey for the troops from Moscow back to Kovno. And this simply is using straight lines to connect these locations. So let's now look at the troop strength dataset and see how we can explore that using point value plot. So here you can see that we have a bunch of geo positions and the troop strengths as a list that are associated with those positions. So we can plug that into point value plot, and then we can use this option here to specify that we want to represent each of those locations as a pie chart that reflects the troop strength at that location. And so we can see here that at the beginning of the invasion, we start off with about 340,000 troops. And as invasion goes along, you can see how the troop strength starts to decline. And at the end of the invasion in Moscow, we are left with about 100,000 troops. We can also visualize this in a different way using Geograph Plot. This is the same troop strength information, but we are encoding it in a different way. Here we are using Geograph Plot to give it a specification in terms of the edges of the graph, and then we are associating a value with each of those edges. And so if we take the journey from Kovno to Moscow for the troops, these are all the edges from between the vertices for each of the cities. And then there's troop strength that's associated with each of those edges. And when we plug that into Geolistplot, we'll get a plot which shows the path of travel for the troops, and it encodes the troop strength in using the thickness of the line as well as the color. And we also get a nice legend which shows the correspondence between the thickness of the line and the troop strength. So if we were to continue doing this for the entire invasion as well as the return, this is what it would look like. I'm using a different color function so that the color is different and how it changes over the path of the invasion and back. I'm also using a method option to specify to Geograph Plot, Geograph Value Plot, that I wanted to plot all of the edges no matter what their thickness is. Because by default, Geograph Value Plot will try to not plot some edges beyond a certain threshold. But in this case, I want to see all the edges, and that's why I'm plotting it. But you can see how quickly it falls off. So we start off with about 340,000 troops, but the line gets really thin on the way back, and we're left with about 4,000 troops here. So what I'm going to do is I'm going to stick with just one encoding, which is the color. And so I'm able to force the thickness of the line using edge value sizes. So I don't want it to encode the troop strength into the thickness, but I'm using just the color to rely on interpreting how the troops are going down in number. And so that brings me to the end of the exploration of this data using these new features. And I can then finally assemble all of these visualizations into a nice little dashboard, which is interactive to look at the different aspects of the data. So I think that brings me to the end of the talk. I hope you enjoyed it, and thank you very much for attending. And I'll take a look at the questions, if there are any now, and try and answer them.